love the intro music at React Rally, and I don't know many conferences that do that. I love that feature here at React Rally. So yeah, as mentioned, I'm going to be talking about data fetching in React server components. I'm going to start off with just a little intro about myself. So I grew up in Texas. I live here in Utah now. I work at a company in Lehi, Utah called Job Nimbus as a software engineer. I consider myself self-taught. Love working with Postgres, TypeScript, React, that kind of stuff. And this is a picture of my wife and I and our youngest child on a trip we did this last summer. The timer's already going down, so we're going to jump right into it. Today, I'm going to give a little introduction about React Server Components, what those are, talk about how we got to React Server Components today in React, and then we'll get into the meat of fetching data, some different options that you can do to fetch data in Server Components, and then some data loading strategies. So once we talk about how to fetch data, we're going to talk about when you can do that in React Server Components. Now I'm going to give an oversimplified version of React Server Components. Stick around for Kent's talk later. He's going to go much more in depth than I probably will, and probably teach it a lot better than I can as well too. But React Server Components is not to be confused with server-side rendering. Those are two separate things, even though they both have server in the name. And it's not a replacement for client components. The idea, as we'll see in this talk later, is that React Server Components are going to work hand in hand with both server-side rendering and client components. As the name suggests, they are only run on the server, and they stream HTML to the client. You can fetch data directly from them, from the server, hence my talk, as we're going to see today. And they are not shipped to the client in the main JS bundle. So they're not part of that big bundle that goes to the client. So let's look at the code here. A traditional client component that we all probably either know or hate at this point looks something like this, where we've got a couple node modules at the top doing some cool stuff. Thanks for the open source people there. We've got a page component. It's got a page prop coming in, a useState hook. It's got a use effect in there that's doing a good old fetch of some API, grabbing a content that's specific to a page. We're obviously going to set that data inside the fetch, and then using our node packages there, we're going to render HTML. Right? So pretty typical client component of fetching data. Some of the issues with this, though, as we all probably come and know, is that everything in this file is going to be bundled up. So those two relatively large node modules at the top are going to be gzipped and sent down to the client all at one time. So all that data is going to be sent to the client. A React Server component, this is just a teaser. We'll get more in depth on it later on. But this is doing the same thing. So this is a server component here, using still those two same NPM packages there, a page component, getting a prop, but you'll notice here that we're actually grabbing the file from the server directly inside of our React component. We're not doing any kind of fetch or data request here. We're actually grabbing that information from the server based on that page prop, sanitizing the HTML, and then rendering an HTML to the client. And what you'll notice here is that those two node modules, they're not going to be included in the bundle that goes to the client. So this stays on the server, and this information is not going to be sent down to the client. And then what's even better is you can partner this with server-side rendering to create an HTML for speed improvements to your application. So major difference between server components and client components is server components cannot re-render. So you can't use hooks in them like use effect and use state or context. Anything that's going to be involved user activity in it, that needs to be on the client components. And server components can't re-render. So let's go through a little history lesson of React. This is, again, an oversimplification, but just to kind of get you in the idea of how we got to where we are and some of the issues that server components tries to address. So at the very beginning, we have create React app, right? So everything was JavaScript, client-side rendering, and the flow kind of looks like this. A user navigates, you see initial blank white screen as a request is made to our server. The server is going to respond back with our payload, our JavaScript, everything all bundled up in a large file, unless you're code splitting, but even then, those can grow to be quite large. Your initial HTML loads, you see some type of loading indicator or a skeleton of some kind. Your use effects fire at that point, going to go get more data from your server, which then responds back, causes a re-render, and the user can interact with the site. So we all probably know this and recognize this pattern. It's what we've used for years. Issues with that, if you care, is SEO for your applications. Keeping secrets secret on your client can be an issue as well. And obviously there's issues with your internet connection and low-powered devices. So then phase 2 of React came in. We've got SSR and SSG that's come in, pioneered by Next and Gatsby, and there's a bunch of others as well. But this kind of helped mitigate the SEO and helped get to paint quicker. So as a user navigates to your site and that request is made to the server, there's a render that happens on the server side. This sends down HTML and JavaScript now, so not just a JavaScript file is sent, but you get a lot more information that's sent with it. HTML, JavaScript gets you faster that first paint. User gets to see it. They can click on like A tags, HTML elements. But there's a hydration level that happens for any activity that needs to be added to client components. And then your user can interact. However, this also has some issues as well. Everything's going to have issues. Everything has trade-offs, right? But this one is, with these two, it's kind of an all or nothing when it comes to the HTML and the JavaScript. So all of the JavaScript needs to run sometimes twice on the server and the client. And you have to fetch everything so that all the HTML has to be rendered and all of the hydration has to happen in order for both being able to see the HTML, interact with it, and also all of the hydration needs to happen for any activity to happen. And so to help kind of mitigate and combine these two paradigms, we have React Server Components, which I mentioned before, sends less JavaScript to the client. There's less hydration work that ends up happening. And we don't need to wait till all the HTML is created. And because React Server Components can stream HTML as it comes in. And we'll see what that looks like here in a little bit. So as a user navigates in this scenario, your React Server Components are rendered on the server, and you'll stream down a HTML payload as well as a JavaScript bundle for your client components. That'll all go to the client. You can partner it, though, with server-side rendering to also send down HTML. So you're sending down HTML, you're streaming HTML, and you can send down a JS bundle as well. Your user gets to see the site. You still get that benefits of a quicker first paint. There's still going to be a hydration for client components. But with this, you can pick as a developer what can be client components, what can be server components, and it's not going to be an all or nothing. And you can construct your UIs depending on how your users are best going to need them. Of course, there's going to be issues with this as well. I've heard that, I haven't done this, but I've heard there's issues with CSS and JS on these components. Tailwind works fine, apparently. And then, obviously, I mentioned before, you can't re-render, so if you're trying to use hooks and stuff on server components, it's not going to work out very well. So looking at this scenario, this is like a typical UI flow of a component tree here. As developers, I mentioned that server components aren't a replacement for client components. It's a way that we can pick and choose what we need to at certain times. So in this case, you've got blue is server components. It's going to be titles, descriptions, maybe more static content. And then things that are going to be interactive, we can make green client components. And you can construct your tree of React to come in and work. And the blue can either be rendered as HTML, or we can stream that in dynamically as information is gathered from our server and as data is fetched on our server components. So in order for this to work, it's not just React out of the box. The caveat here is that you have to work tightly with a bundler, with a server, with a router. So currently, it only has worked, as far as I know, with Redwood, JS, which was announced recently, and then of course Next.js is App Router. So this is where you can use server components in these two environments currently. Other platforms have mentioned adding support for this as well, so you might see more support come out for server components here in the future. All right, so let's get to the meat of it. How do we fetch data in React Server Components? I've narrowed it down to about 4 different ways that we can do this inside of our server components. We can use async await and fetch server resources directly from within our components. We can create a server action. We can use the tried and true fetch, web API fetch API method. And then there's third-party libraries that have support. We're going to talk about Tanstack query or React query in this one. All right, so first up, I kind of already gave a teaser of this in the third slide when we were talking about server components. But for server components, you can create these server components to be asynchronous. So client components can't be asynchronous, but you'll notice in this example here, this page component is asynchronous. And you can see that we're working with Prisma in this example, where we're grabbing the users from our database and awaiting that. So yes, that return is going to be suspended. So that return of JSX, that HTML, is going to be suspended until the users come in. So no use effect here. We're just going to grab any kind of server resources. And obviously, you can make this much prettier and extract this into more of an MVC type architecture. But this is the gist of it, is you can just asynchronously await and grab any kind of server resources that you have on your server. And as I mentioned, React's going to suspend that UL and those users, that mapping of LIs until that information comes back. And what's even cool is you can partner that with Suspense, so you don't have to do any kind of conditional logic rendering to show a loading spinner or some type of loading experience. So in this case, we've got blog posts, and it itself is going to be awaiting, grabbing posts from our database. And you'll notice that below, instead of our page component, we've wrapped it with Suspense and passed a fallback component. So this is going to be our loading skeleton, our loading spinner. So as blog post is awaiting, grabbing that data information, that server, and fetching that information there, Suspense is going to render that loading experience for us. So there's no if else here, there's no loading spinners that we're adding in. Conditionally, Suspense is going to figure that out for us. And it's going to, once that information comes in, it's going to stream down to the client. React's going to pick it up and render it accordingly. Second way we can fetch data within server components is you can use a server action, which these came out at the same time that server components did, so they're still pretty experimental. So I suggest playing around with them first before you go too far with them. But what's cool about these is you can call them on the server as well as on the client because they're just exposed server endpoints. And you'll be able to catch and recognize a server action by this use server directive that's at the top of the file, inside the code block or at the top of the file. So what that code looks like is, in this example, we've got a function here called create note action. It's asynchronous. You'll notice that we have this use server directive that's inside the function block. And you can tell that it's awaiting creating a new note to our database directly. And then this action, this function that's defined inside the server component is then passed to a button of some kind. And that function is called, this is going to do work on our server. So it doesn't need to be in a server component. You can extract that away into a different function called a server action. And that can do that work for you. And as I mentioned before in the other bullets, is that you can extract this away into its own function or file. So by moving that use server directive at the top of the page, your client components can reference this. So what that looks like here is we have a client component. You'll notice that it's client component in our app router because we've got the use client at the top. Server components don't have any syntax. They don't have a use server or a use server component. If you're using app router in Next.js, it's a server component by default. So this is a client component because we're saying it is. We're importing in that create node action from above, which is a server component. And so the bundler, the platform that you're using is going to create an exposed endpoint for you, and this client component can call directly, update that data on our server for us by using this server action. And these server actions, unlike what we're going to see next, are not cached by default. For the third option for data fetching, we can just use the good old-fashioned fetch on the server, and that way it works because Next.js is extending that for us. So if you're using fetch, the syntax will look the same. It's just lowercase fetch, and you pass it that first URL to begin with. But behind the scenes, Next is doing a lot of stuff to it, so it's caching it. You could pass a bunch of config options to it. But here we just have a function. It's just inside of get data. We're fetching some other system, some other backend, some other API layer of getting data. And then inside of our page component down at the bottom, we are just calling that. So this page component is a server component. You can tell that, first of all, by the asynchronous, and that there's no use client at the top. And directly in this component, we can await it and go and get that data by just using fetch. And for the fourth option I'm putting down here for fetching data is you can use third-party libraries like React Query or Tanset Query, that's what it's also called. And you also might know it by that name. The setup for this, unfortunately I don't have time to go through it all, but it's actually really similar to how you would set it up on the client. You have to create a new query client inside of your component. And behind the scenes, React Query is going to do all of the caching for you. It's going to do the retries for you that we all know React Query to do for us. You can invalidate this code pretty easily by other methods that come in with React Query. But you can do some prefetch, there's some pretty cool stuff you can do with React Query. You can prefetch, as you might be used to just fetch query if you're using it with client, but you can do some prefetching that you can do inside of client components just by passing it in some type of function of what to go get, and then React Query behind the scenes will do all the hard work for you. You'll notice down at the bottom, unique to React Query is in order to get all the context and the queries to work behind the scenes, you got to wrap your components with this hydration boundary. And this is going to make sure that server rendered state syncs correctly with the client when the app loads. So go check out the documentation on that, on how to get that up and running. It's actually only a one-pager. So it's pretty easy to use React Query to do the data fetching on your server components. You might be wondering why you'd want to use React Query when Next.js, I mentioned, already does caching behind the scenes for you. And it actually might make sense for you not to. It even says that in their documentation. Some reasons why it might make sense for you to use React Query as the go-to option as you're building with server components is maybe that you're already using it inside of your project and you want to kind of start adding in some server components, and so it might make sense to keep using that on the server and getting it to work. And then also I mentioned that Tanset Query, this is what it's created to do. It's been around for a while now. It's kind of nailed down the logic of caching and reinvalidating, and we're all probably more familiar with that. So maybe you want to use it just because you're more familiar with it. That's another good reason as well. And as I mentioned, the prefetch data, React Query does a great job of that, and that's the expectation is as you're working with React Query, you want to use it as a way of prefetching data and just getting data and not doing anything more than that, like using that context and spreading it throughout your application. It's just a place to get server data and have that rendered to the client. All right, now that we kind of seen some of the options of fetching data, we don't need to have the use effects and wait for the client to first load spinners and then you go back to the server to grab data. Now that we know some of the current strategies around how to fetch data in our server components, we can talk about the when to fetch data. And there's kind of two types of ways of when to load data. You can either do it sequentially, so one after another as data comes in, or you could do it in parallel. So let's say that we've got a page tree parent-child relationship that looks like this. You've got like your root parent component, it's rendering a dashboard layout, and you've got a settings page, and that needs data itself. There's two different ways you can do that if you're building with server components, and it's pretty cool depending on how you want to use it. But sequentially, just as the name suggests, you can have data load in one at a time. Maybe you have data that you don't want to load, it's conditional, and so you want to only load it as things come in. You can do that, and we'll see in the next slide. Or if you know that your users are going to get all the same data every time, and you don't care about unnecessary requests, you can have it all be wrapped up and fetched in parallel. So nested components will fetch sequentially as they're rendered. So let's look at the code for that. We've got two components. We've got a playlist up at the top, and we've got a page component. Inside of playlists, we're doing an await here that's going to go and fetch some data. So this is going to go, you can assume it's going to some type of either its own server or another API where we're fetching data. And then inside of the page component, it itself is also fetching data, and both of these have an await on them. So inside of the return down here, we're rendering playlists, the top component inside of here. So what's going to happen is page is going to suspend its return until that artist data comes back. And then it's going to render playlist, the component at the top, which then it will kick off its get artist playlist function at the top. So this is going to create that sequential loading of data. And this might make sense, as I mentioned. Maybe you conditionally render playlists, and you only want to see it if someone clicks on something, or there's some type of, I don't know, interactivity, or depending on the user's token, they only render certain data here or there. This more tightly couples data to the component that cares about it, versus just doing one big fetch at the beginning of everything and having all that data, even if you might not need it. And then parallel is pretty easy. It's something we probably already do with if you use like Redux and dispatch everything and use effects, or you just fetch everything. But here we've got two different API requests here. We've got two different fetches. We've got getting artists and getting artist albums, these two functions here. And then inside of this page component, we're just going to get both of them, and we're going to pass it to a promise at all. And so this is going to do that parallel request. Both of these are going to fire at the exact same time, and we're going to suspend the return at the bottom until both of those come back. And so both are going to be loading. This obviously has its pros and cons. Maybe you want to show the name first and not have to wait for albums to come in. And so maybe it doesn't make sense to wait for everything to come in before you show that data and have that data be there on the client. And that's why I said, as developers, we can choose what makes sense for our application, what we care about as far as speed and the user experience. All right, quick recap here as we close. React Server Components, it's not a replacement for client components. It's just a new component that gives us another tool in our tool belt that renders ahead of time on the server. It's stable right now, but still experimental. We can fetch data asynchronously, unlike client components. Directly, we can grab server resources directly, or we can use fetch. There's currently support for third-party libraries to help us with that data fetching with React Query and that caching behind the scenes. Even Next.js will do that caching for us. As we use some of these data fetching things, we don't have to worry about doing all the state management of data. That information is already stored and cached for us. We just need to use those tools inside the platforms. And then finally, once we know how to create and fetch data in our server components, you as a developer can choose how you want your data to be fetched instead of our components, either sequentially or in parallel. And that's all I have. Thank you. I'll post all these slides in the Slack channel. Thanks.